Welcome to Machine Learning Lesson 1.2. In this lesson, we're going to cover the platforms that we're going to use to explore machine learning, as well as review an example. Google has an application called Colab, which makes it very convenient to explore machine learning online. It already has all the libraries loaded, so you can get right to it. Colab is something called the Juniper Notebook. So if you do any kind of research online, looking up, machine learning in Python, you might come across this term called Juniper Notebook. A Juniper Notebook, think of it like the shell part, the interpretive shell of the Python IDE, where you're able to run code immediately. It becomes very convenient, but you do have to get kind of used to it, especially because most of you are used to creating programs in a file and then running the whole file. So you kind of have to detach your mindset from that. We're going to look at a little bit of Python. Again, this is by no means a Python tutorial. There's assumptions that are being made throughout this video series that you might not be familiar with Python, but at least you're familiar with programming. Concepts such as variables, objects, functions. But again, if you're familiar with Python, that's great. If you're not, you should be able to follow along with the examples once we get to the actual instructional videos. Again, this video is just an overview. So let's get to it. So, like I mentioned, Colab is a Google application. So I find that the easiest way to do it is just to type in Colab. I'll do it down here on the search bar. Colab. And it'll pop up. And you'll see that it's collabresearch.google.com. Come up. And because it is a Google application, it will be saved in your Google Drive, just like a Google Doc, a spreadsheet, a slide, or Google Form, any of those Google application products. So let's create a new notebook. And let's go ahead and title it. We'll do Machine Learning Lesson 1, 2. Okay. So as I mentioned earlier, I want you to think of this like the interpretive shell of the Python IDE, in that you simply can write code, print, let's say, and I'll make my screen a little bigger. Print, let's say, hello world, and hit that. And it's going to print that. Okay, cool. So this is called a code block. So I can type let's say a variable. Let's say name equals Castro. And I can run that and it'll execute. I can add multiple code blocks. So these, if you notice, there's a play button next to each of these, meaning you can run them independently. So down here I can write, print name. And it's going to remember the variable from the previous section. So you can share information. Let's add another one. So let's say hobby. Hobby, and let's say program. So I got a variable there, and we'll just clear out this output. And let's say I want to go down here and let's go ahead and print hobby. You might say, well, hobby is not defined. That's an error usually when Python doesn't recognize the variable. And you might say, well, the variable's up here. Anytime you include information in a code block, you must run it. Just because you typed it there and you press play in a different code block doesn't mean it runs that one. And so that's something you'll get used to. So you might say, well, why create different code blocks? Why just have one big code block? With machine learning, you have very distinctive steps. I'll bring this back up. Okay, we talked about in the first lesson. You got these 7 steps. It's very convenient to set up each of these steps as its own code block. So that way, if you run a particular code, you can check to see if there's an error in that particular step, and not necessarily have to run your whole program. Okay. Plus, you'll know some other benefits later on when you're training your model. Some models might actually take an hour to train. So let's say you make a change in your program after you train the model. You don't want to have to wait another hour before you can check to see if the change makes. you can simply run those code blocks afterwards. As I mentioned, this is not a full-blown tutorial. This is about as much Python as I'm going to cover. Again, the assumption is that you're familiar with variables, if statements, and objects and functions. So let's get to an example so we actually can see what machine learning looks like. So the first step is we got to load the libraries. So you can see here, there's some libraries. This is scikit-learn, the matplotlib, as we mentioned, and pandas. I'm going to go back to the slide. If you recall, these are the three libraries that we're going to use to kind of explore machine learning. And the first step is to get some information. So pandas has this great little function called readCVS, which will allow us to grab some information. And then, let's take a look at it. So the information we're grabbing here, it's about automobiles and their miles per gallon and a bunch of metrics, a bunch of features about the car, such as the number of cylinders, the horsepower, the weight, the acceleration. So what we're looking to do with our machine learning model is see if we can find a way to predict how many miles per gallon we get from a car based off one of these features. Okay, so now that we kind of got a sense of the data, our next step is to analyze the data. And this cannot be understated. If you kind of look back at the cycle, you have 4 steps simply dedicated to data. And if you look at it in terms of actual machine learning, it's 1 step, 2 steps. That's it. Again, think of machine learning. You're teaching the machine something. You got to make sure that the information that it's learning from is correct. If it's not, you're going to get a bad model. If you get a bad model, then the whole application is worthless. So again, it's very important that you understand the data, that you know what kind of data you're feeding into your machine so that you get good outcome. So we've got a couple of things we can do with our data. We could describe the data, which gives us, an average, the minimum value, the maximum value, different quartiles, a standard deviation, all great things to kind of analyze our data. To go a little further, we can do little histograms about each of our features, because that's the thing, we got to analyze these features. We got to see what they look like. Again, this is just an overview. I want to state this again. I'm going through this quickly. These are things that you'll be learning throughout this video series. So what we're looking at here is a distribution of, each of the features. So obviously acceleration has a nice little distribution, and this helps you to learn a little bit about the data. You can see here there's spikes in the 4, 6, and 8. That's because that's how typically cars go. I haven't seen a car with 7 cylinders. I'm actually kind of questioning the 3 and the 5, but again, I'm not a mechanic. Maybe there is a car with 3 cylinders. Who knows? Okay. So again, this is one way of analyzing your data by simply looking at the distribution of each of the features. Another good way to analyze the data is to see a correlation between the features. So this is how miles per gallon is correlated to cylinders, the displacement, the horsepower, weight. What you will notice that across the diagonal of this, they're all 1s. Because if you think about it, I'm comparing miles per gallon per miles per gallon. It should be 1. It's the same thing, so the correlation is 1. So 2 numbers to think about when you look at correlations, 1 and -1. 1 means that it has a positive correlation, that when one thing goes up, so does the other one. But that doesn't mean that -1 is a bad. Any kind of strong correlation is a good thing. So if you get close to -1, it just simply means the opposite, that once something goes up, the other one goes down. So we can see here, just based off of just look at the first line, cylinder seems to have a good negative correlation with miles per gallon. Horsepower seems to have a good one. Weight has a good one. So is displacement. You could also compare different ones. So let's see displacement and cylinders. Wow, that's a very strong correlation. So the number of cylinders that our car has definitely affects the displacement. And displacement is just, kind of volume of the car. Okay, so let's say numbers aren't your thing though. You have a hard time looking at numbers. So guess what? We can use Mathplot to visualize the data. And that's what Mathplot does. So let's take a look. Nice little color. And we see that if it's closer to the yellow, then that's a positive correlation. If it's closer to the purple, that's a negative. So this really reflects the same thing that the numbers are, except visually with colors. Again, another great way of looking at the data. Another way that we can look at the data is something called a scatter plot. Again, these are all things you're going to learn in future videos, which kind of gives you a mapping of each of the features against another one. So same idea, miles per gallon versus all of the other features. So we already saw that. Oops, let me scroll back up on this one, scroll back down on this one. We saw that these had negative correlations. And this is what a negative correlation looks like, that it's slanted this way. As well as this is displacement. This has a positive correlation. If I had to guess, this is probably weight. Let's take a look. Scroll down a little bit. Horsepower. But if we look right next to the weight was also positive. And we saw that from the color graph because it's yellow. Here's displacement. Horsepower and weight are yellow, so that's a positive correlation. And then we simply look at it from the numbers too, that displacement, horsepower, and weight had positive numbers. Again, it cannot be understated. When you do machine learning, you must analyze your data. All right, so we're going to kind of go down, go down, go down. Okay, now that we've kind of analyzed it, let's take displacement as our selected feature to predict the miles per gallon. So in this one, we're actually kind of gathering the data. We're preparing the data to train our model. And notice, it's one line of code. Well, this one actually just splits the data into two sets, one to test and one to train. This is the one that actually selects the data. We're actually selecting the columns, miles per gallon, and the displacement. These two small little lines is all you need to train your model. When we say train your model, that is machine learning. When you create a model, you are creating a machine learning application. So notice it's only 2 lines of code. In some other models, it might take a little bit more, but that really is all there's to it. Because the library does all the heavy lifting of the math involved to train the model. So the other thing we need to do is that once we train them, we got to see how good our model is. So this is where we use our test data. So the result is we got a 70% essentially accuracy based off our test. It's not great. It means it's well enough to kind of predict something, but it might not always get it correct. So once we've trained the model, we really kind of test it out. Let's visualize it. So we'll go back to the math plot. So this is our displacement. So we're going to map our feature, which is displacement. And this is our linear regression model. Because that's what we've done. We've done a linear regression model. We've done a line of best fit. So this is what the computer is going to use to try to predict our miles per gallon based off our displacement. Now, the reason I bring this chart up is, again, we got to go back to this. You got to understand your data. Look how the data is distributed. There is a large distribution of our data. It's not really centered around the line. So again, this is the reason our percentage is 70. It did a good job, but there's a lot of other factors involved with the miles per gallon. And hopefully your gut feels that, just simply the size of a car isn't going to directly impact the miles per gallon. Hey, how old the car is can impact it. How much horsepower the car has can impact your miles per gallon. Obviously, if you have one of these, souped up Chargers, you're going to use up some gas as compared to very conservative, just heavy vehicle. So now we've kind of visualized it. What is the purpose of all this machine learning? Well, the purpose of the machine learning is to actually be able to make predictions. So what we've done here is that we've extracted a sample from our data at random, and we printed it out. So we've selected this car, the Datsun, and it gets 27 miles per gallon and has a displacement of 97. So what we do with this line is that we feed our model the 97 and we look to see what it predicts for us. So in this case, our model predicted that a car with 97 displacement will get you 29 miles per gallon. Is it correct? No. We can see that the actual car got 27. But again, this is a prediction. And again, our machine learning model scored 70%. So 70%, and it got it within, looks like 2 miles per gallon. That's not bad. So this is an example of machine learning, just one example. And again, I went through it very quick, simply because I wanted to be able to kind of inspire you what a machine learning application might look like. Let's go back to our presentation. So we introduced, in machine learning lesson 1.2, we introduced Google Colab, which is a Juniper Notebook that will allow us to use Python to explore machine learning applications. And we've kind of finished off with an example of a linear regression machine learning model. So hopefully you're excited. Don't let the fact that it looked like a lot of code. It will become very easy as you go through the videos. Enjoy.